In this video, I am going to talk about series and some related definitions. However, before I talk about series, let me go ahead and talk about sequence a little bit. What is a sequence? From an ordinary person's perspective, a sequence is nothing but a list of items. Okay? A sequence is nothing but a list of items. However, in mathematics, we define sequence a little bit more formally. A sequence is a list of items, but the list contains infinitely many items. And this is how we denote typically. Let's say A sub 1, A sub 2, A sub 3, and it keeps going forever. This is a list of items. A sub 1 is the first item in the list, A sub 2 is the second item, and so on and so forth. There is a compact way of expressing this as well, which is A sub n, okay? Then that n goes from 1 to infinity. That's just a compact way of saying that this is the list. This is the expanded form, and this is the compact form. Yet, there is a formal official definition of sequence in mathematics. A sequence maps a natural number. So you could think of it as a function, okay? A function maps something from domain to range. A sequence maps a natural number n to, let's say, real number r. Okay, now what is n here? This n is nothing but 1, 2, 3, and etc. The set of natural numbers. So this is kind of like the official and formal definition of a sequence. And you could express the items, individual items in the sequence also this way. F of n is equal to A sub n. That means this n comes from the set of natural numbers, and this A sub n is actually some real number or some number. You can think of it that way. So this is just the official definition of sequence. However, what is series? Series is nothing more than just adding up the individual terms in the sequence. So that means you have this term A1, A2, A3. So a series is just the sum of the items in a sequence. And that's how it's written. And again, a series has also a compact form. So this is nothing but summation n is equal to 1 to infinity A sub n. Now, this is Greek letter sigma, uppercase sigma, and we use it for summation. This is just a compact way of saying that I am adding all the numbers A1, A2, A3 up to infinity, right? All of them, and this is the compact format. So this subscript n, it starts at 1 and it goes to infinity, which is the same as saying is going to be A sub 1 when n is 1, plus A sub 2 when n is 2, plus A sub 3 when n is 3, and it keeps going. Now, here are a couple of examples of series. So here is one. 1 plus 1 half plus 1/3 plus 1/4, and so on and so forth. This is a series. It's kind of a special series, by the way. It's called harmonic series. Please keep it in mind. You'll see it, and very special series. It's called the harmonic series, and it does in fact diverge. It does not converge. Okay. Now here is another example, which is 1 plus 1 over 2 square plus 1 over 3 square plus 1 over 4 square plus ... This series, however, it does converge. So it does converge. And later on, you will see that this is an example of what we call P series. P series, okay? P series, just to give you an idea, it has the following format: summation n is equal to 1 to infinity 1 over n to the power p. This is how it looks like. By the way, this is also an example of p series. This a harmonic series when p is equal to 1, and this one is also an example when p is equal to 2. Now let me talk about some of the properties of series. By the way, series you could just add, subtract, multiply, technically divide as well under certain circumstances, so long the denominator is not 0. But all of these operations you can perform on series with only one condition. You have to make sure is that the series converges. The series between which you are making the operations, they have to converge. So if you have two series, let's call them, so let's write down the first property. Okay, so summation n is equal to 1 to infinity a sub n. This is one series, let's say it converges. And then summation n is equal to 1 to infinity b sub n. That's also another series, it converges. So you could add them to get a new series. Summation n is equal to 1 to infinity a sub n plus b sub n. So you could add them. And again, you could subtract too, right? So you can subtract it. Now, you could multiply a series. Okay, so let's see. We have a series, summation n is equal to 1 to infinity a sub n. If you multiply this series by a constant, so this first, our assumption is that this one converges, this series converges. Let's say we multiply it by some constant c. All right, so which is the same as saying that summation n is equal to 1 to infinity c times a sub n. So c is a constant, it really doesn't depend on the subscript, so you could just pull it outside. And of course, this is not as common, but it is also possible if you have two series both convergent. Okay, summation n is equal to 1 to infinity a sub n, and another series that's also convergent, summation n is equal to 1 to infinity b sub n. You could technically multiply them. Okay, and division similarly. Again, when you're doing division, it becomes multiplication and division, both of them, it becomes a little bit more complicated. And when you're dividing, you kind of have to make sure that you are not dividing by 0. I hope that this discussion was helpful. Thank you very much.